Okay, so here's H-25. Here we have 4 local or relative extrema cases. This first case, we've got a local max, and f prime is undefined, and therefore so is f double prime. If f prime is undefined, then you can't take its derivative, so f double prime is undefined as well. Local min, with a similar case where f prime is undefined and f double prime is undefined. But then over here we have the smooth cases. Okay, you have a local max. If it's like a smooth local max, it will be the case that f prime is equal to 0, because you'll have a horizontal tangent, and f double prime, in this case, if you've got a smooth local max, then the graph is, remember f double prime tells you about concavity, the graph is concave down, so f double prime is less than 0. If you've got a smooth local min, f prime is 0, but the graph is going to be concave up, so f double prime is greater than 0. Okay, those are the smooth cases. So calculus tests for local or relative extrema. For absolute extrema, you need the candidates test. We did that earlier in this cycle. That's where you put the things, you put the endpoints and the critical numbers between them in a table and you get the outputs. Yeah, that's for absolute extrema. Absolute means highest or lowest overall. Local or relative just means highest or lowest within a certain neighborhood of y values around it. So first derivative tests for local extrema. You need the f prime number line. This will always work. It will work no matter whether you have smooth local maxes and mins or these pointy ones. And it tells you this. It says that if x is equal to c, if x equals c is a critical number, okay, remember a critical number is where f prime is 0 or undefined, and f prime changes from positive to negative at c, then f has a local max, and then local min is just the opposite. Now the second derivative test, this is what is new. All right, that's what's new. The second derivative test for local extrema, you don't need a number line, but it doesn't always work. Okay, so this test I think is can be faster, but it doesn't always work. And what it says is this: if f prime of c equals 0 and f double prime of c is less than 0, then f has a local max at x equals c. And then if f prime of c equals 0 and f double prime of c is greater than 0, then f has a local min. So it's just, basically stating what I did in these pictures. Okay, so we're going to do a second derivative test example. And then below it, I showed the same example, but with the first derivative test purely, so you could see the difference. Okay, so identify the values at which this function has local maximums and minimums. Use the second derivative test where applicable. In your practice, there's 3 examples, and it asks you to use the second derivative test where applicable. Because remember, you can't always use it. So to do the second derivative test, first you take the first derivative, f prime of x. Okay? And then you find the critical numbers by setting the first derivative equal to 0. So you've got to figure out where this equals 0. Okay, so I could take out 15x squared. And then what do I have inside? I have x squared minus 4. Then the critical numbers are x equals 0, x equals 2, x equals negative 2. Okay. Then you take the critical numbers and you put them into the second derivative. Okay, so now I take the second derivative, so f double prime of x, and you go back up to this one, equals 60x to the third minus 120x. Okay, yeah. And then you're going to plug these numbers into the second derivative and see if it's positive or negative. Okay, so f double prime of 0 is 0. Okay. So guys, this is only going to work if you get a positive or negative value for f double prime. So for this, we need the number line on f prime to tell. Okay, so the second derivative test can't tell us anything here about x equals 0 because when you plugged it into the second derivative, 0 came out. So you can't say anything about the concavity of f unless f double prime is positive or negative. Okay, so I'll come back to that one later. F double prime of 2, I plug it. All right, so this is 60, 2 to the third, minus 120 times 2, 240. Okay, so this is greater than 0. Greater than 0. Okay, so at x equals 2, f prime equals 0 and f double prime greater than 0. Okay, so this means horizontal tangent, and then this means concave up. So imagine that you've got a horizontal tangent and concave up. So it would look like this. So it'll be like, therefore, local min at x equals 2. All right, I'll section all of this off. Okay, so there's the second derivative test on that one. Now let's do f double prime of negative 2. All right, so 60, negative 2 to the third. Well, that's negative 240, less than 0. So at x equals negative 2, f prime is 0 and f double prime is less than 0. And you don't have to say all of this. It's not asking for an explanation. But this, I'm doing the explanation for our notes though. So we've got a horizontal tangent, and then this is telling us concave down. Right, so it's going to look something like that, f. Okay, so yeah, so f will look something like that and that. I'm just making a video. Therefore, local max at x equals negative 2. Okay, now, remember, it didn't actually end up working. We didn't get positive or negative for 0. So you've got to do the number line, but only at 0, okay? So I got to do the f prime number line. I'll put all 3 critical numbers on there, but we only need to do a test at 0. Negative 2, positive 2. And I put the other 2 critical numbers on there just because we don't want to pick a testing point. If I just picked 0, maybe you would pick a testing point that was beyond these 2, and you don't want to do that. So like I'll pick negative 1 and 1. Now, this is the f prime number line. So I'm plugging negative 1 and 1 into f prime up here. All right, so if I plug negative 1 up here, I end up getting positive, negative, okay? So this is a negative, that's a negative interval. I'm looking for a sign change at 0. And then if you plug 1 in, you get, again, positive, positive, negative. Okay, so here we had no sign change at x equals 0, so no extrema there. Okay, now when you go to do your practice, guys, I'm pretty sure you're not going to get anything like this. I think you could just plug right into the second derivative. But if you ended up getting 0 on the second derivative or undefined, then you couldn't use the second derivative test. Okay, the second derivative test, you don't need the number line for it, but it doesn't always work. So just to summarize, I did the second derivative test for these ones that it would work for, and then this one it wouldn't work for, so I had to go back and try this, these first derivative tests where I'm looking for a sign change on the number line. Okay, so there's 3 examples to do.